Good morning, pilot teachers and students. Good morning, class.
Good morning, sir.
All right, thank you. You may sit down. All right, today's topic of discussion will be on voltmeters. Now, in our last lesson, we looked at or we studied the voltage and also the charge. Looking at this, now the voltage has to simply come from a voltmeter. Now that is the instrument that is used to measure the voltage. Now if that voltage is given, that tells you that the amount of energy is been given to a coulomb of charge. So in this lesson, when we're going through and then looking at the voltmeters, we'll be looking at, we'll be also studying how you can connect the voltmeters and so on. So I will now ask you to go through, right? There is no further explanation. You can go through now, the pilot students as well. Your teacher will now instruct you to go through and then have these notes down quickly. And then after the end of the notes, I will give you some few questions and activities. Okay, that is an instrument used to measure the potential difference of the voltage. Right. Here is the second. Now, one thing that you will find about these voltmeters is that they have a very high resistance. So when you are connecting these voltmeters, make sure that they are in parallel with a component, okay, whether it is a light bulb or it is a dry cell or battery. So when you are connecting, especially the voltmeters, make sure they are in parallel with the component because they have very high resistance. Right, so I will be asking one of you to come up and then probably connect these ones later on. All right, so here is the next. All right, for that, voltmeters must always be connected in parallel with the or across the component in question. Right, the reason why they have to be in that is because they have a very high resistance, and you will find that no current will be flowing through these voltmeters. By now we should be finished with writing down that information on the voltmeter. Okay, I will now give you the next. Okay, when we are connecting, especially the voltmeters, you'll find that the positive of the red terminal of the voltmeter must be connected to the positive of the dry cell. Okay, simply write this one. Okay, that is the positive. Okay, red terminal. Okay, that is the positive, and then you have the negative of the voltmeter. So what happens is that it must always go back to the positive of the dry cell or any power source that is coming in. So that is how you can connect them. Now in here you find that there are two sets of terminals can be found. One is the 1 volt terminal, and then you have the other, which is, all right, this is one, and the other one will be the 5 volt terminal. Okay, either way, if you are connecting these voltmeters, and if one of them, the positive is in 5, then you will have to take the reading from the scale which has 5. If it is from 1, then you will read from the scale which has, okay, from 0 to or 0.1, and then you have 0.2, 0.4 up to 1. So if it is 1, if you are connecting that to 1 volt terminal, you take that from the 1 amp scale. If it is for 5, you take it from the 5 volt scale. Okay, 5 volt scale. All right. Okay, here is the next. All right, that is the question. So those are the questions. So the pilot students, you can also go through and then copy these questions. They're question number 1, 2, and 3. And after that, as you watch, I will ask the model students to come up and then probably connect these voltmeters in parallel circuit. And they will also give us the reading from those or what they measure. So what you can do now is to quickly go through and copy those first 2 questions. I will give you another one later. Question number 1. Okay. Question 2. Okay, probably you can use the diagrams. You will have to connect the circuit. Okay, so and then you can explain whether it is in parallel. Okay, so connect the circuit using those 3 cells, and also I will ask you to do that later. Okay, probably two of you can do that. Okay, connect those cells and then place the voltmeter that can measure the potential difference. Okay, here is question. Okay, question 3 and 4. Question 3 says, explain why current is affected in a voltmeter. Okay, that is question number 3. And then you have question 4, which is explain the difference between EMF. Okay, that stands for electromotive force. All right. Okay. that is for electromotive force, EMF. And then you have this one, that is for, okay, good, potential difference. All right, this is another example of KD, or another name for this. Question number 3. 3. Okay. This, let me see. You willing to try question number 4? Who is willing to? Which one of you is willing to try question number 4? Any one of you? Okay, you go for question number 4. Rachel, question number 4. All right, those are the 4 questions. You can go through quickly. I'll give you some time to do those questions. And I will be asking also one volunteer from the class to come up and then probably connect the circuit and show us, okay, how the voltmeter can be connected. So you have dry cells here, and also there is a circuit board here. Okay, those are the dry cells which are in there, holders. And then you have the connectors, and also this one should be the, what is this? All right, very good. It is a switch. So I will just leave it here. There will be, or I will ask one of you to come up and do that. All right, Michael, you will later when you go through question number 1, 2, and then you can go and then do that. Finish writing those questions. Okay, you work on those questions. Okay, work on those questions quickly. Okay. Yeah.
So this affects the flow. It affects the flow.
The first?
It affects the flow of the because it gets very high current, very high resistance.
That's right.
When it's small,
Yeah.
current is big.
That's right. When you put it in, what is this? Parallel. Because when current comes, it has to split up. Yeah. And then the other half is going in one of these. It messes in other words that But otherwise, in a series, what happens is that once it messes it, especially when you are connecting straight, it will never, because current will never pass through and then give the reading to that voltmeter. Who was chosen for question number, or number 1 is on that side? Okay, 2 will be. Okay, go through quickly and then you finish answering those questions. All right, go through quickly and then finish them. All right, what does question number 1 says? Yeah, where must a voltmeter be connected? Okay, in parallel. Okay, it's almost the same relation to question number 3, but you have to explain in terms of current. Okay. Yeah, that's right. A diagram should be shown. Okay, just show the diagram and component, and then you show whether. Okay. Talk side. Makanya permanent. Samuel. Who's this? Maureen. Can you tell Sula? Okay, Samuel. You move over here. Okay, move your chair over this way. Okay, because he's going to move this way. Okay, you come sit here. Get your book and then you come over here. Okay. Can you just move one step in, because the desk could be moved this way. That's it. Bex. Use that side of the board. Not this one. That side. Yeah. Okay, you finished writing down, or were you for question? Okay. You go for question number 4. Okay, probably you can write a definition or explanation down. Just some. Yeah, yeah. Have you done that? Okay, okay. All right, we will now go through the answers to those questions. Question number 1, 2, 3, and 4. Right. For question number 2, right, one person is going to come up and then have the diagram on the board, while I will ask 2 students to come up and then show that by connecting the voltmeters in. Okay, in that second board. So for question number 1, we will have Garrett. Okay. Pastor.
Must be connected in parallel because it has a high resistance.
Right, you have heard the answer. His answer is voltmeters must always be connected in parallel because they have very high resistance. Right, so that is quite correct for to question number 2. Question number 2, Nathaniel, you can come up, and Michael and Rachel. Okay, you come and then you connect it. You can start now, quickly. Okay, bring yours over here. Later you can get it. Yeah. That's it. Okay, maybe there is no component only this one. Yeah. One more over there on that side. That's it.
Okay, we've connected the voltmeter in parallel because, as Kurt has already said, the voltmeter is high resistance. In this case, there is no component, so we just connected it wrong. But if you were connecting a circuit, the voltmeter would have to be connected parallel to the component. So the component would be here, and positive terminal. The the electrons are flowing this way. The current is flowing this way. So the voltmeter is connected to the positive side, positive terminal, and the black side is connected to the negative terminal to measure the potential difference.
And there, okay. Just change and then you change this way. Get that measure here. Yeah, you can. Yeah.
No, it's okay. It's okay. Just leave that. Just change that voltmeter. Okay, remove those and then you tighten it.
One over there and one over here. That's it. Okay, one over there, then one there. Yeah.
Okay, you can also explain that. The other one is correct. You go through this and then you explain that again.
So now what we've done is we've connected it directly to the cells, and the volt, as you can see, the volt being measured now is around potential difference now being measured is around 4.5 volts.
All right, very good. Firstly, we'll just look at question number 2 and then, all right, this diagram is quite correct. If you have to have this one, all right, that is a component which is that is a lamp or bulb. And you have to connect that in parallel with the component. So in here, right, since that is negative, so we have to have negative over here, and this one should be positive. So from positive it goes to positive, and then from negative it goes to negative. All right, looking at the real component here, that is a diagram from Michael and Rachel's explanation. That is correct. Okay, they don't have a component in place, so it was supposed to be a component here so that the voltmeter would be connected parallel. But this time there is no component. But you can also measure or connect that voltmeter by having it next to the cell like this. So that measures that is in parallel, but it has to measure the potential difference that is going through the circuit. So that is how you can connect. But especially when you are connecting, you may have something like a lamp or resistor in place over here. So that measures the amount of potential difference that is going through or flowing through this circuit. Right, we'll go on to the third question. Question number 3 will be John.
Current is affected because a voltmeter has a very high resistance which only allows small current to pass through.
Okay, it has very high resistance and it allows only very small current to pass through. Okay, excellent. Now, we will move on to question number 5. Rather, question number 4. Okay, question number 4. Right, Michelle, you can go to the board and then write your answers down quickly. Right, just clean that little area. All right. Yeah, you clean this one. Yeah. After this.
The difference between EMF and potential difference is electromotive force is the force that drives a charge around a circuit, and the potential difference is the voltage produced across an electrical device. What they share in common is they both share the common measurement unit of volts.
Okay, very good answers. You can see those are the answers to the fourth question. EMF or electromotive force is a force that will drive the current in the circuit. That is for EMF. PD is simply the potential difference, and it is the voltage produced across an electrical device, or it is simply the amount of energy that is given to each coulomb of charge. Right, looking at the force and also the energy, you find that work is done when a force is moved through a distance. And in here you have force, but this energy is given from that PD. Now anyway, the common factor in here is that both of these have to share the same unit of measurement, which is volts. Okay, very good. So those are the answers to question number. That is the answer to question number 4. You have been given answer to question 1, 2, 3, and 4 as well. So quickly go through and then right. To summarize what we went through in this lesson, simply a voltmeter is an instrument which is used to measure the voltage or the potential difference. Now, voltage is simply the amount of energy that is given to each coulomb of charge. Now, having to that, the voltmeter must always be connected in parallel with any component that you use. So in that way, you will not damage the voltmeter, or simply because the voltmeter has a very high resistance, and that only less amount of current will be flowing through each one of those or the circuit. All right, so that brings us to the end of the lesson. Now in our next lesson, we'll be also going through and then looking at one of the other measuring instrument which is used in electricity. So that is the ammeter. All right, so pilot students, if you have any questions, you can go ahead to ask questions. Okay, probably I'll give you a few minutes. And also more students, if you have any questions, you can ask. All right, very good. Everything is quite clear. Now our keyword for today will be voltmeters. Good afternoon, pilot teachers and students. Good afternoon, class. All right, thank you very much. You can sit down.